So in this video, we are going to start with fourth set of class 10th mathematics standard. And let's move on to the first section, that is section A of MCQs of 1 marks each from 1 to 18. And the first question says that we have to find the ratio of HCF to LCM of least composite number and the least prime number. And let's first of all write down the least composite number. So least composite number is 4 and least prime number is 2. Okay, now let's find out the LCM HCF of 4 and 2, which is 2, and LCM of 4 and 2 is 4. We have to find the ratio. So ratio of HCF to LCM is equal to 2 by 4, which is so 1 by 2 means A is the correct option for question number 1. Let's move on to question number 2. Okay, for question number 2, we have to find the roots of the quadratic equation. And the quadratic equation is 3x squared plus 3x minus 10 is equal to 0. Now we know that to find the root, we can use the factorization method. So A is the quotient of x squared, B is 3, C is minus 10. And if we multiply A with C, which gives us negative 10, so we have to find the factors of negative 10 so that when multiplied gives negative 10 and when added gives 3. So these are 5 and minus 2. So 5 into minus 2 is negative 10 and 5 minus 2 is 3. So let's split the term, middle term. So instead of 3x, I'm going to write 5x. So 5x minus 2x minus 10 is equal to 0. And let's take common in the pair of the terms. So this is 2x plus 5 is equal to 10, which gives us x plus 5 common, x minus 2 is equal to 0. Now the product of two terms is 0 when either one of them is 0. So we don't know which one is 0. So let's assign. So either this is 0 or this is 0, which gives us x is equal to negative 5 and x is equal to 2. So here the correct option is negative 5 and 2. So negative 5 and 2 is the first option. So A is the correct answer. Okay, let's move on to question number 3. Okay, for question number 3, we have to find the next term of the AP. And it's given that the AP is root 6, root 24, and root 54. Now, this root 24 can be written as 6 into 4. Yeah? 54 is 9 into 6, so this gives me root 6. Root of 4 is 2, so it's 2 root 6, and root of 9 is 3, so it's 3 root 6. Now, this is the AP where first term is root 6, and the common difference is 2 root 6 minus root 6, which is root 6. We have to find the third is the it's given that we have to find the next term, that is the fourth term. So fourth term is a plus 3d, or you can add root 6 to the third term. So if we add root 6 to the third term, that will give us the fourth term, which is 4 root 6. But we don't have any of the options here, so let's just square this, which gives us 96. So this is the root of 96. So it's 4 4s are 16, and 16 into 6 is 96. So root 96 is the third term. Okay, for question numbers 4, we have to find the distance of the point 1, negative 1, comma 7 from x-axis. So for question number 4, negative 1, comma 7. So negative 1 is here, and 7 is, let's say here, let's say this is the point in the second quadrant, negative 1 comma 7. So its distance from the x-axis is the y coordinate. So this is the perpendicular distance from the x-axis, which is 7. So its distance from the x-axis, this is the x-axis, the distance from the x-axis is the y coordinate, which is 7. So this is the option B. And for question number 5, for question number 5, we have to find the area of a semicircle of diameter d. And so for question number 5 is diameter is d, then radius is the half of the diameter. Now area of uh, a semicircle is half of the area of the circle. Area of the circle is pi r squared. For semi, it has to be divided by 2. Let's put in the respective values of r. So r is d by 2. So this is d by 2 the whole square divided by 2. And this is pi into square by 4 by 2, which is pi d square by 8 square units. So our option is option C. So correct answer for this is option C. For question number 6, we have to find the empirical relation between mode, median, and mean of a distribution. And in our book, it's given that 3 median. Okay, it's given that 3 median is equal to mode plus 2 mean. So 3 median is equal to, so this is question number 6. And in our book, it's given that NCRT textbook, it's given that 3 median is equal to mode plus 2 mean. So this is mode plus 2 mean. This is mode. Now, all these empirical relations are given in terms of mode. So let's try to find out mode from here. So this is mode. Let's shift it to the left hand side. So it becomes 3 median minus 2 mean. So mode is equal to 3 median minus 2 mean, which is option A. So option A is the correct answer for this, which is mode is equal to 3 median minus 2 mean. So mode is equal to 3 median minus 2 mean. And let's move on to question number 7. Okay, for question number 7, we given the pair of linear equations. So 2x is equal to 5y plus 6. And let's write it down in the standard form, which is, let's shift them to all these terms to the left hand side, which is 2x minus 5y minus 6 is equal to 0. So here a1 is 2, b1 is negative 5, and c1 is equal to negative 6. Now the second set of pair of equation is 15y is equal to 6x minus 18. So this is 16x minus 15y minus 18 is equal to 0. And let's write down the respective coefficients of x, y, and the constant. So a2 is 6, b2 is negative 15, and c2 is negative 18. So a1 by a2 is 2 by 6, which is 1 by 3. b1 by b2 is negative 5 by negative 15, which is 1 by 3. C1 by C2 is negative 6 by negative 18, which is 1 by 3. Now, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2 is equal to 1 by 3. And this shows that these are the coincident lines. So our correct answer for this is option C. Let's move on to question number 8. Okay, for question number 8, it's given that alpha and beta are the zeros of the polynomial. So our polynomial is x squared minus 1, which gives me x squared is equal to 1. and x is equal to plus minus 1. So our first 0 is 1 and second 0 is negative 1. And if we try to add them, so alpha plus beta is 1 minus 1, which is equal to 0. We can also do it in this way. So coefficient of x squared is 1, b is 0, and c is negative 1. And we know that alpha plus beta is minus b by a, which is 0. So you can do it either way. And this will give us the answer D. So D is the correct option. Let's move on to question number 9. For question number, we are on question number 9. And for question number 9, it's given that a pole of 6 centimeter high. So this is, let's say, the height of the pole. Casts a shadow 2 root 3 meter long on the ground. So this is the pole which is 6 meter high, and this casts a shadow of 2 root 3 meter on the ground. We have to find the sun's angle of elevation. This one with the shadow. So let's say this is theta, the angle of elevation, sun's elevation. Now, for this angle, we have the perpendicular and the base, and we know that the ratio of P by B is tan theta, so P is 6 by 2 root 3, which is equal to 3 root 3. And if we rationalize this, which is equal to 3 root 3 divided by 3, which is equal to root 3. Now tan theta is equal to root 3, and we know that tan 60 is root 3, which gives us theta is equal to 60 degree. So that means the sun's angle of elevation is 60 degree, and option A is the correct answer for this. Let's move on to question number 10. Yeah, on question number 10, we have to express secant theta in terms of cot theta. Now we know that 1 plus tan squared theta is equal to secant squared theta. Now for tan I can write it as 1 upon cot. So this is 1 upon cot squared theta. And then let's take LCM here. So this is cot squared theta, and this is cot squared theta plus 1, which is equal to secant squared theta. Now secant squared theta, so secant theta is equal to under root of 1 plus cot squared theta upon cot squared theta, and this is 1 plus cot squared theta, and root of cot squared theta is cot theta. So secant theta in terms of cot theta is under root 1 plus cot squared theta upon cot theta, which is option C. So option C is the correct answer. For question number 11, it's given that two dice are thrown together. So the total outcomes for two dice thrown together are, we have to find the probability. So let's get the total outcomes, which are 36. Now the probability of getting the difference of numbers on their upper face equal to 3. So number of outcomes where difference of two numbers, so the difference of two numbers is 3. Now it's not mentioned whether it has to be the first phase or the second phase. So we have to just make sure when the difference of the two numbers is 3. So the first one is 6, 3 and 3, 6. Next one is 5, 2 and 2, 5. So 5 minus 2. So it's the 5 on the first phase and the second on the second die. 2 on the first die and 5 on the second die. Doesn't matter because it's not mentioned whether it has to be the first or the second, so we'll consider those. And the next one would be 4 1. So this is 4 1 and 1 4. So these are total of 6 cases for the outcomes, and total favorable outcomes are 6 and total are 36. So this is 1 by 6. So 1 by 6, that is the option C is the correct answer. Let's move on to question number 12. Before question number 12, it's given that the given triangles are similar. The triangle ABC is similar to triangle PQR and ACBCQR are given. So if the triangles are similar, that means their corresponding sides are in ratio. This is the symbolic form. So AB by PQ is equal to BC by QR. So this is BC by QR, which is equal to AC by PR. So this is AC by PR. Now BC. AB and PQ are not given, so we will not consider this. BC is given, which is 5. QR is given, which is 3. AC is given, which is 6. And PR is given, which is X. So multiplying this gives 5 into X is equal to 3 into 6. So X is equal to 3 into 6 by 5, which is 18 by 5, and which is equal to 3.6 centimeter. So 3.6, that is the option A for this. Let's move on to question number 13. Okay, for question number 13, we have to find the distance of the point -6, 8 from the origin, and the coordinates of origin are 0, 0. So let's say this is point A, this is point B, and the distance between these points is AB, and we know that the distance between 2 points is given by the formula x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is x1 y1 and this is x2 y2. So x2 minus x1, this is 0 minus of -6 the whole square plus y2, which is 0 minus 8 the whole square, and this is now 6 square, which is 36, 8 square, which is 64, which is root of 100, and that is equal to 10. Now this is 10, which is option D. Let's move on to question number 40. Okay, for question number 14. So this is the figure, and the figure is given that PQ is a tangent with center O, and OQ is the radius. So we have to find OPQ is equal to Y, OPQ is equal to X, and QOP is angle Y. We have to find the value of X plus Y. So this OQ, so OQ is perpendicular to the tangent because we know that radius is perpendicular to tangent at the point of contact. So that means angle Q is equal to 90 degree. So this is 90 degree, and then we can use the angles of property in the triangle. So 90 plus x plus y is equal to 180 degree. This is because of the angles of property of a triangle. So this gives us x plus y is equal to 180 minus 90, which is equal to 90. So x plus y is equal to 90. So B is the correct option for question number 14. Okay, for question number 15. Now TA is a tangent to the circle. So this is the tangent to the circle with center O and OT. Distance of the point T from the center of the circle is 4 centimeter. Angle OTA is 30 degree. We have to find the length of TA. So we have to find the length of TA, and for that, let's join this. So when we join OA, so if we join OA now, OA is perpendicular to TA because we know that radius is perpendicular to the tangent at the point of contact. Now, so that means this is 90 degree. So angle O8 is 90 degree, and in this right angled triangle, that is OTA, we can use. So for this angle, this is base and this is hypotenuse. So we are going to use the T ratio cos D is equal to B by H. Cos 30 is root 3 by 2. Base is TA, hypotenuse is OT. So this is root 3 by 2 is equal to TA by OT is 4. So 2 2s are 4, and this gives us the tangent's length, which is 2 root 3 centimeter. So this is 2 root 3 centimeter, which is the option A. Let's move on to question number 16. Okay, for question number 16, it's given that PQ is parallel to BC. So PQ is parallel to BC, and PB is, this is 6 centimeter, AP is 4 centimeter, and AQ is 8 centimeter. We have to find the length of AC. Now PQ is parallel to BC, though that means AP by PB is equal to AQ by QC by the BPT theorem. Now AP is 4, PB is 6, AQ is 8, and it's QC. So let's cross multiply this. This is 4 to the 8, which gives QC is equal to 12 centimeter. So QC is 12 centimeter, but we have to find AC, which is 8 plus 12 is 20. So option B. So AC is equal to AQ plus QC, which is 8 plus 12 is equal to 20 centimeter. Okay, for question number 17, it's given that alpha and beta are the zeros of the polynomial, and we have to find the value of 1 upon alpha plus 1 upon beta. So let's write down the given polynomial. It's 4x squared minus 3x minus 7. So A is 4, B is negative 3, and C is equal to negative 7, which gives us alpha plus beta is minus b by a. So minus of minus 3 by 4, which is equal to 3 by 4, and alpha beta, which is a part of the zeros, is c by a, which is minus 7 by 4. Now we have to find 1 upon alpha plus 1 upon beta. So 1 upon alpha plus 1 upon beta is equal to alpha beta is the LCM, which gives me beta plus alpha. Now let's put the respective values. Alpha plus beta is 3 by 4, and alpha beta is negative 7 by 4. So this is now minus 3 by 7. So minus 3 by 7 means option D is the correct answer for this, for question number 17. For question number 18, it's given that a card is drawn at random from a well shuffled of 52 cards. So total cards in deck of cards, that's equal to 52. Now the probability, we have to find the probability that a card draws is not an ace card. So number of ace cards are 4, and non-ace cards will be 52 minus 4, which is 48. So we have to find the probability of picking up the non-ace cards, which is 48 by 52. This is 24, 26, and 12, and 13, which is 12 by 13. So the correct option for this is option D. Okay, for question number 19, it's given that the suggestion and the reasoning based question. Suggestion says that the probability that a leap year has 53 Sundays is 2 by 7. Now, a leap year has 366 days, and we have to find the probability of 53rd Sunday. So, number of weeks in a year are 52 weeks. So 52 weeks means 364 days. Now 2 weeks means we have 52 Sundays, which is equal to 364. So in 364 days, we have 52 Sundays, and for that the probability is 1, because we will get 52 Sundays in 52 weeks, obviously. And now for the leap year, we are left with remaining days. If we take out 364 days in which we have 52 Sundays, we have to find the 53rd one. So remaining days, 53rd Sunday will be in the remaining days. So remaining days are 366 minus 364, which is 2 days. Now these 2 days can be either Sunday or Monday and Tuesday, Tuesday and Wednesday, Wednesday and Thursday, Thursday and Friday, Friday and Saturday, and Saturday and Sunday. So we have total of 7 options, and to find the 53rd Sunday, so 53rd Sunday is and this. So the probability of 53rd Sunday is 2 by 7. So that means the assertion is correct. Now the probability that non-leap year, non-leap year has 365 days, and for that the probability of 53rd Sunday in that. So these in that the probability of the, so for a non-leap year, so non-leap year has 365 days, and 52 weeks will only make 52 Sundays. So 52 Sundays are in the 52 Sundays are in 364 days. Now we are left with 1 day. 364 minus 365 minus 60, 364 is 1 day. Now this 1 day can be Sunday, the Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. We have total of 7 options, and out of these, the 53rd Sunday is only one, which is 1 by 7. So the reason, or the second reason, is it's not 5 by 7, it's 1 by 7. So reason here, the assertion is true, but reason R is false. So C is the correct answer for this. Let's move on to next question. For question number 20, it's also an assertion in the reasoning based question. So it's given that A, B, C are in AP if and only if 2B is equal to A plus C. So A, B, C are in AP and we are given the results. So A, B, C are in AP means B minus A is equal to C minus B. So shifting B to this side gives 2B, and this is now A plus C. So this is true. Now the sum of first n odd natural numbers. So sum of first n odd natural numbers is 1, 1, 3, 5, 7, and n. So it's an APA is 1, B is equal to 2, sorry, D is equal to 2, which is the common difference, and we have to find the sum. So this is n by 2 into 2A plus n minus 1 into D, which gives us n by 2 into 2 into A is 1, n minus 1 D is 2, which gives us n by 2, 2 plus 2n minus 2, 2n 2 gets cancelled. So this is 2n squared by 2, which is equal to n squared. Okay, so this is also true, but this is not the correct. This is also true, but this is not the correct explanation of the first one. So both assertion and reason are true, and reason R is not the correct explanation of assertion A. So this is option B for question number 20. For question number 21 of section B, which comprises of very short answer questions of 2 marks each. The first one says that two numbers are in the ratio 2 is to 3. So let the two numbers be 2x and 3x. Let the two numbers be 2x and 3x as they are in the ratio 2 is to 3. Now the LCM of these two numbers 2x and 3x would be, x is common, so this is x, and 2 and 3, the product, its LCM would be 6x. So the numbers which are different, we have to take the product, and which are common, we have to use them once in the product. So LCM is 6x. but LCM is given, which is equal to 80. So 6x is equal to 80, which gives us x is equal to 30. And now the two numbers are 2 into 30 is equal to 60, and 3x is equal to 3 into 30, which is equal to 90. We have to find their HCF. So HCF of 60 and 90, the highest common factor for these two is 30. So the HCF of the numbers are 60 and 90, and HCF of both of them is 30. Okay, for question number 22, it's given that one of the zero of the polynomial is reciprocal of the other. So given polynomial is p of x is equal to 6x square plus 37x minus k minus 2. And let's write down the respective coefficient of x square, x and the constant. So a is 6, b is 37, and c is equal to negative of k minus 2. Now it's given that 1, 0 is the reciprocal of the other, so let the zeros be alpha and beta, and let alpha be the reciprocal of beta. Now we know that alpha beta is c by a, so alpha is 1 by beta, c is negative of k minus 2 by a, which is 6. So this is 1, and which gives us 6 is equal to negative k plus 2. Negative k is equal to 4, which gives us k is equal to negative 4. So the value of k is negative 4 for question number 22. Okay, for question number 23, part A, we have to find the sum and product of the roots of the quadratic equation. This is part A, and the quadratic equation is given by 2x square minus 9x plus 4, where a is equal to 2, b is equal to negative 9, and c is equal to 4. We have to find the sum and product of the roots. So we need not have to find the roots because we know the sum of the roots is given by negative b by a. So negative of negative 9 by 2, which is 9 by 2. So this is the sum. And alpha by beta is the product, which is c by a. So this is equal to 4 by 2, which is equal to 2. So the sum and the product of the roots is 9 by 2 and 2. And let's move on to part B of the same question. We have to find the discriminant for the quadratic equation 4x minus 5, where a is equal to 4, b is equal to 0, and c is equal to negative 5. And we know the discriminant is given by b square minus 4ac, so b square is 0 square minus 4 into a into c is negative 5. So this is plus 4, 4, 16, and 16 into 5 is 80, which is greater than 0. And we know that when d is greater than 0, the roots are real and distinct. So the roots are real and distinct. And let's move on to question number 24. For question number 24, it's given that a fair coin is tossed twice. We have to find the probability of getting at most one head. So this is question number 24, and in this case, the total outcomes when the coin is tossed twice is 2 square, which is 4. And we have to write down the outcomes. So the half of 2 is 4, so 2 head, 2 tail, and half of 2 is 1. So 1 head, 1 tail, 1 head, 1 tail. And it's given that the at most one head. At most one head means 1. So 1 head and less than 1 head, which means 1 and 0. So the probability of at most one head will be 1 head. So this is 1 head here, 1 head here, and no head. No head means we will have to include tail as well. So these are the favorable outcomes are 3, total are 4. So the probability is 3 by 4. For question number 24. For question number 25, part A, we have to validate it for these angles, and it's given that 5 cos square 60. So cos 60 is half. So that is half square plus 4. Secant 30, which is the reciprocal of cos 30. So this is 2 by root 3, the whole square. And 45 is 1. So 10 square 45 is 1 square. Now sine 30. So sine 30 is 1 by 2. So this is 1 by 2 the whole square plus cos 30. And we know that cos 30 is root 3 by 2. So this is root 3 by 2, root 3 by 2 the whole square, which gives us this is 5 by 4 plus 2 square is 4, 4 into 4 is 16, root 3 square is 3 minus 1. And this is 1 by 4 plus 3 by 4. We can take LCM here. So LCM is 12, and this is 15 plus 16 into 4 is 64 minus 12 upon this is 1 by 4 plus 3 by 4 is 4 by 4. So this is 1. Now this is 15 plus 64, 5 plus 4 is 9, and 79 minus 12 by 12, 9 minus 2 is 7, 7 minus 1 is 6, 67 by 12 is the answer for the first part, 67 by 12. Let's move on to this part B. So for part B, it's given that A and B are acute angles, and it's given that sine of A minus B is 0. Okay, we are on part B, for which it's given that sine of A minus B. So this is part B, and it's given that sine of A minus B is 0. And we know that the angle for which sine is 0 is sine 0. Sine 0 is 0, so this gets cancelled, and A minus B is equal to 0. This is our first set of equation. For second, it's given that 2 into cos of A plus B. So 2 into cos of A plus B minus 1 is equal to 0. So this gives cos of A plus B is equal to 1. And cos of A plus B is equal to half. And we know that cos 60 is half. So this is cos 60, which gives us A plus B is equal to 60. Now A minus B is equal to 0, and A plus B is equal to 60. Solving these two equations, if we add them, which gives us 2A is equal to 60 and A is equal to 30 degree. So if A is 30, we can also subtract these equations. So A minus B is equal to 0 and A plus B is equal to 60. If we subtract these equations, this gives me minus 2B is equal to minus 60, which gives us B is also 30. So A and B, both the angles are 30 degree each. And let's move on to section C. Okay, for section C, question number 26, part A. We have to find the number of terms in an AP whose first and fifth terms are. So first term is minus 14 and fifth term is a5, which is 2, and we know that fifth term is a plus 4b, which is equal to 2. We know the value of a, so minus 14 plus 4b is equal to 2. 4d is equal to 2 plus 14 is equal to 16, which gives us d is equal to 16 by 4, and which is 4. So d is equal to 4 and a is equal to 14. Now it's given that the last term is, so last term is 62. Let's consider this term as the nth term whose number is not known. So we know that a n is a plus n minus 1 into d is equal to 62. Let's put in the value of a, which is negative 14 plus n minus 1 into d is 4 is equal to 62. So n minus 1 into 4 is equal to 62 plus 14, which is 676. And n minus 4 is equal to 7654. So this is 4 ones are 4 and 9s are 36. So n is equal to 19 plus 1 is equal to 20. So there are total of 20 terms in this AP. Okay, for part B, we have to find the first negative term, and negative means less than 0. So for part B, as I told you, we have to find the first negative term, and negative means less than 0. So it's the part B, and for this RAP is 65, 61, 57, 53, and goes on like this. So here A is 65 and common difference is 61 minus 65, which is equal to negative 4. And we have to find the first negative term. So let's say the negative term is nth term, which is negative is less than 0. So nth term is a plus n minus 1 into d is less than 0. So a is 65. We have to find n. D is negative 4 less than 0. So this is n minus 1 into negative 4 is less than negative 65. So negative negative as gets cancelled, this inequality sign changes to this is 4 here. So as soon as we cancel out negative signs, the sign of inequality changes. So this, the sign of the inequality changes. This is now greater than, and I will let you know. So out of minus 3 and minus 4, we all know that minus 3 is greater. So when we remove this sign, that is the negative sign, now the 4 is greater. So that's how we got this, the inequality sign reversed. So n minus 4 is greater than 65 by 4. So it's 4 ones are 4, 25, 6 are 24, and 2, 5. So n minus 1 is greater than 17.25, and the integer which is greater than, so this is n. So n is greater than 17.25, and we know that an integer greater than 17.25 is 18. So 18th term is the first negative term, and we can also calculate that. So 18 is a plus 17d, a is 65 plus 17 into negative 4. So this is 65 minus 7 4, that is 28, 65, which is negative 3. So negative 3 is the first negative term. And this solves our question number 26. And let's move on to the next question. Okay, for question number 27, we have to prove that root 5 is an irrational number. And this is question number 27. We have to prove that root 5 is an irrational number. Okay. Now let's say that root 5, let root 5 is a rational number. So root 5 is equal to a by b, where a and b are co-primes. So co-primes means that a and b are do not have any common factor. So co-primes means the numbers like 3 and 5 and 3 and 5 do not have any common factor. So these are co-primes. So a and b are not divisible by any other number except 1. So let's cross multiply this. So this is root 5 into b is equal to a, and square on both sides will give us 5b square is equal to a square. So 5b square is equal to a square means, so this is 5b square is equal to a square means that 5 divides a square. So this implies now 5b square by a square means that this is a square and 5 is dividing let's say a square. So this gives us a square is equal to 5b square using division algorithm. So this implies that 5 divides a square. So 5 divides a square means 5 divides a. Now 5 divides a means, let's say this 5, it divides a. So it divides a with some coefficient c and gives us remainder 0. So I can write a is equal to 5c, where c is some integer. And now let's put a in the, so put 2 in 1, we get this is 5b square, and a square is 5c the whole square, which gives us 5b the whole square, 25 c squared. So 5 5s are is 25, so b square is equal to 5c squared. Now this means that 5 divides b square. Now 5 divides b square means 5 divides b. So 5 divides b and 5 divides a, but a and b are co-primes. So that means, but a and, sorry, or we can say from a and b, we get that 5 divides a and b, but a and b are co-primes. So that means whatever we have started is conflicting. So that means our assumption is wrong. Hence, root 5 is not rational, but it is an irrational number. And this solves our question number 27. Let's move on to question number 28. Okay, for question number 28, we have to prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact and the center. And let's try to understand and sketch a graph for this. So there is an angle between two tangents drawn from an external point. So this is, let's say, the circle, and the angle between two tangents drawn from an external point. Let's say this is the angle P. PQ and PR are the tangents. O is the center of the circle. Now it's given that this angle is supplementary, that is makes a sum of 180 degree with to the angle subtended by the line segment join the points of contact are Q and R. So if we join the point of contacts Q and R, then they subtend the angle at the center QOR. So this angle is supplementary with P. So now it's given. So we can write that PQ and PR are tangents from external point P. Now we have to prove that angle QPR plus angle QOR supplementary, that is 180 degree. And for that, we all know that angle Q is equal to, so OQ is perpendicular to PQ and OR is perpendicular to PR, because OQ and OR are radius. So the reason for this is radius is perpendicular to the tangent at the point of contact. Now, this quadrilateral in quadrilateral PQOR, angle P plus angle Q plus angle R plus angle O is equal to 360 degree. This is because the angle sum property of the quadrilateral. Now angle P is angle QPR, angle Q is 90 degree, angle R is 90 degree, angle O is angle QOR, which is 360 degree. So 90 plus 90 is 180. So angle QPR plus angle QOR is equal to 360 minus 180. So this is QPR plus angle QOR is equal to 180 degree, and that's what we have to prove. And let's move on to question number 29. For question number 29 part A. So we are in question number 29 part A. We have proved that sine A minus 2 sine cube A upon 2 cos cube A minus cos A is equal to tan A. Now let's consider this LHS, and for the numerator and the denominator we can take sine A common, so this gives me 1 minus 2 sine square A, and for denominator the common is cos A, which is 2 cos square A minus 1. Now we know that sine square A is 1 minus cos square A. So we are going to replace the value here of sine square A. Instead of sine square A, we are going to write 1 minus cos square A. And so here we have used the identity. We know that sine square A cos square A is equal to 1, which gives us sine square A is equal to 1 is cos square A. So we have replaced it. Now we are going to open up the bracket. So this is sine A and 1 minus 2 plus 2 cos square A cos A in square A minus 1. Now this can be written as this is 2 cos square A. 1 minus 2 is negative 1 upon cos A into 2 cos square A minus 1. So this gets cancelled. And sine by cos is tan A, which is equal to RHS. Okay, for the part B, let's move on to its part B, where we have to prove that secant A into 1 minus sine A into secant A plus tan A. Let's consider this. Now secant is 1 by cos A into 1 minus sine A. Now secant is 1 by cos A, and A is sine A by cos A, which gives us this is 1 minus sine A upon. So now if we take LCM cos A for this is 1 plus sine A. Now 1 minus sine A, 1 plus sine A is A minus B into A plus B. So this is A minus B, A plus B, which is A square minus B square. Cos A into cos A is cos square A. Now 1 minus sine square A, so 1 minus sine square A. From this equation we can get 1 minus sine square A is cos square A. So instead of 1 minus sine square A, I can write cos square A, and below is cos square A. So this gets cancelled, is equal to 1. and this is equal to RHS. So this solves our both identities for question number 29, and let's move on to question number 30. Okay, for question number 30, it's given that the two concentric circles are of radii 5 centimeter, 3 centimeter. Now the concentric circles are the circles with common center, and we can draw them like this. So this is the first circle, and this is the second circle, and both of them have common center. Now the bigger one has radii 5 and the smaller has 3. And we have to find the chord of length of the chord of the larger circle which touches the smaller circle. So the chord of the larger circle which touches the smaller circle is, let's say, AB. So this is chord for the bigger one, and for the bigger one the radius is 5. Now the radius of the smaller is 3. So for the smaller this chord is a tangent. And we have to find the length of the chord, that is, we have to find now this radius, let's say it touches the circle at P, so OP is perpendicular to AB because AB is touching the circle, smaller circle, so AB is a tangent to smaller circle, and we can say that the radius is perpendicular to tangent at the point of contact. Okay, now if radius is perpendicular, so that means this is a right angle triangle, and in right angled triangle OPB, square of the hypotenuse, which is OA square, is equal to OP square plus AP square, and this result we have got by using the Pythagoras theorem. So OA is 5 square and OP is 3 square. So this is AP square, which gives AP square is equal to 25 minus is equal to 16. So AP is equal to 16 is equal to 4 centimeter. So AP is 4 centimeter. Now we know that perpendicular from the center bisects the chord. So perpendicular from center, it bisects the chord. So that means AB is equal to PB. So we can write it is 2 times AP. And AP is 4, so this is 2 into 4 is equal to 8 centimeter. So length of the common chord of the circle is 8 centimeter, and this is also question number 30. Let's move on to question number 31. For question number 31, we have to find the value of P for which the given quadratic equation has equal roots, and the given quadratic equation is it's Px into x minus 2 plus 6 is equal to 0. It has equal roots. Now let's get this quadratic equation in the set form. So this px squared minus 2px plus 6 is equal to 0, where a is p, b is minus 2p, and c is 6. So for equal roots, we know that discriminant is equal to 0, and discriminant is given by b squared minus 4ac is equal to 0. So b squared is minus 2p, the whole square is 4 into a is p into c is 6. So this is 4p square minus 24p is equal to 0. And if we take p common, that is 4p minus 24, which gives us p is equal to 0, which is rejected. That means 4p minus 24 is equal to 0, which gives p is equal to 24 by 4 is equal to 6. So the value of p is equal to 6, for which this equation has two equal real roots. We are on Section D, where we have to solve the long answer type questions of 5 marks each. And we are going to solve both the parts of 32nd question. Now, for 32nd question, part A, it says that a straight highway leads to the foot of a tower, and a man standing on the top of the 75-meter high tower observes two cars at an angle of depression of 30 and 60 degree. So this is question number 32 and part A we are doing. And it says that a straight highway, it leads to the foot of the tower. Now, a man is standing at the top of the tower, and from here, so the height of the tower, it's also given it's 75 meter. And from here, he observes two cars, let's say at point A and B, and for both of them, the angle of depression. So for them, we have to make an horizontal at the top. Now, the angle of depression is 30 and 60 degree. Let's say it's car A and car B at on the highway. So it makes an angle of depression of 30 degree with the first car and angle of depression of 60 degree with the second car. So this horizontal is parallel to the ground. So these are the alternate angles are equal 30 and 30 and 60 and 60. So this is the rough sketch. And now one car is exactly behind the other on they are approaching the foot of the tower. You have to find the distance between the two cars. So the distance between the two cars is AB. So we have to find AB. And so let's say let CD is equal to 75 meter be the height of the tower. Now we are going to use the smaller one, the right angled triangle DCB, in which tan 60 is equal to DC by BC and tan 60 is root 3. DC is 75, which gives us BC. So BC is equal to 75 by root 3, and rationalizing the denominator gives us this is 75 root 3 divided by 3, which is equal to 25 root 3 meter. So we have got BC, it's 25 root 3 meter. And now we are going to use the another tan ratio in the bigger right angle triangle, that is ACD. It's tan 30, which is equal to DC by AC. Now tan 30 is 1 by root 3. DC is 75 and AC can be broken into AB plus BC. So this is 1 by root 3, 75. We have got BC, we know the length of BC, which is 25 root 3. And if we cross multiply this, this is now AB plus 25 root 3 is equal to 75 root 3, which gives us AB is equal to 75 root 3 minus 25 root 3, which is equal to 50 root 3. And it's given that we have to take the value of root 3. It's 1.73. So this is 1.73. Now the distance between the two cards is 5 threes are is 15, 7 5 are 35, 36, and it's 8650. So this gives 86.5 meter. So 86.5 meter is the distance between the two cards. And finally, we can write that distance between two cards is equal to 86.5 meter. Okay. So this is our final answer for the part A. Let's move on to part B. So for part B, it's given that from the top of a 7 meter high building, the angle of elevation of the top of a cable tower. So uh, For part B, it's given. We are going to part B, and part B, it's given that from the top of a 7-meter high building. So let's say this is the 7-meter high building, and from its top, the angle of elevation of the top of a cable tower is 60 degrees. So angle of elevation is 60 degrees. So this is the angle of elevation to the top of the tower, and let's say this is our tower, and this is the ground. Both are standing vertically on the ground, and if we label them, let's say AB is the height of the tower and CD with the height of the building. It's given that height of the building is 7 meters, so this is 7 meter, and the angle of elevation, so angle of elevation to the top of the tower is 60 degrees, so this angle is 60 degree, and the angle of depression of its foot is 30 degree. From the top, the angle of depression to the foot of the tower is 30 degree, so this is 30 degree, and this is a B. So if this is 30 degree and this is also 30 degree, because we have drawn this A, B, C, D, E, let's say this is E. So this is perpendicular. These two lines are parallel. These are alternate angles. So this is equal. So if CD is 7, then EB is also 7 meter. And we have to determine the height of the tower. So we have to find AB. And to find AB, so AB is equal to AE plus EB. We already know EB, which is 7. So that means we have to find A. So let's get started with the triangle BCD. So in right angled triangle BCD, we are going to use the tan ratio tan of 30, which is CD by BD. So tan 30 is 1 by root 3, CD is 7. This will give us BD. If we cross multiply this gives us BD is equal to 7 root 3 meter. Now, BD is equal to EC is equal to 7 root 3 meter. So we have got EC as well, which is 7 root 3 meter. Now let's use the tan ratio in right angle triangle AEC. So in AEC, it's tan 60 degree, which is EC, AE upon EC. So this is A upon AC tan 60 is root 3. A we have to find out, and EC is 7 root 3. So if we cross multiply this is A will be 7 root 3 into root 3, which is 7 into 3 is equal to 21 meters. So we have got AE, and now let's put the value of AE, which is 21 plus 7, and that gives the height of the tower. So height of the tower is 28 meters. So this solves our question number 32. Let's move on to question number 33. Okay, for question number 33, part A, it's given that D is a point on side BC of triangle ABC. So we are doing question number 33, part A. And it's given that D is a point on side ABC of triangle ABC. So let's say this is our triangle ABC, and D is a point. So this is triangle ABC, and D is a point on the side BC of triangle ABC such that, so it's given. Like it's given that angle ADC, this angle ADC is equal to angle BAC. And we have to prove that CA square, to prove that CA square is equal to CB into CD. Now let's prove that, and for that CA belongs to side CA and CD. So CA and CD belongs to triangle ADC. So one of them, this triangle is triangle ADC, and CB belongs to triangle ABC. So we are going to prove that these two triangles are similar, and for that it's given that angle ADC is equal to angle BAC. This is given, and angle C is equal to angle C, which is common. Therefore, by a similarity rule, triangle ADC is similar to triangle. Let's write it in symbolic form. So ADC, D was equal to angle A. So this is A and C. So these are the triangles that are similar. This is angle ADC. I can write it triangle BAC. So this is CD by CA. So this is CD by CA is equal to CA. So this is CA by CB. And when we cross multiply this gives us a desired result. So CA square is equal to CD into CB. And this is what was asked to prove. Let's move on to part B, where it's given that AD and BM are medians of triangle ABC and PQR. So this is triangle ABC and triangle PQR. They have these medians. Okay, so this is triangle ABC and a triangle PQR. So AD is the median and PM is the median. And it's given that triangle ABC is similar to triangle PQR. So let's write down what is given to us. AD and PM are medians of triangle ABC and triangle PQR respectively. Are medians of triangle ABC and triangle PQR respectively, and also it's given that triangle ABC is similar to triangle PQR. Now it's asked to prove that AD by PQ, so it's AD by PQ has to be equal to AD by PM. That's what we have to prove. Okay, so these two sides, AD by PQ and sorry, AB by PQ, this is AB. So AB by PQ and AD by PM, this belongs to triangle ADM and PQM. So we have to prove that these two triangles are similar. And for that, let's take the help of triangle ABC, which is similar to triangle PQR. So if these two triangles are similar, that means AB by PQ. So this is AB by PQ should be equal to BC by QR, because corresponding sides of similar triangles are in same proportion. Okay, now BC, this BC can be written as 2 times BD, so this is 2 times BD, and the QR can be written as 2 times QM, so this gets cancelled, and AB by PQ is equal to BD by QM, and we get this result because BC is equal to 2 times BD and QR is equal to 2 times QN, as AD and PM are medians. Okay, now we have got the sides in proportion AB by BD is equal to AB by PQ is equal to BD by QM, and also angle B is equal to angle C, because these are the corresponding angles of similar triangles. Angles of similar triangles are equal. So from this, we get by SAS similarity rule. So this gives us by SAS similarity rule the triangle ABD. So triangle ABD is similar to triangle PQM. And once these triangles are similar, their corresponding sides will be in proportion. So we can write AB by PQ is equal to AD. So AD by PM. So AD by PM. And okay, so this solves our question number. We have to prove that AB by PQ is equal to AD by PM, and we have got the desired result by proving these two triangles are similar. And this solves our question number 33. Let's move on to question number 34. We are on question number 34. And in this question, a student was asked to make a model shaped like a cylinder with two cones attached to its ends by using a thin aluminum sheet. So this is question number 34. And student was asked to make a model shaped like a cylinder with, so this is, let's say, the cylinder. And to the cylinder, there are two cones attached to its ends by using a thin aluminum sheet. So these are the two cones attached to its ends. And the diameter of the model is 3 centimeters. So this is the diameter of the model, which is 3 centimeter. This is 3 centimeter in total length. So the total length of the model is 12 centimeters. So this is the total length of the model. And if each cone has a height of 2 centimeters, so this is the height of the cone, which is 2 centimeter. Each of these cones has a height of 2 centimeters. So this is the height. Now we have to find the volume of air contained in the model. To find the volume of the air contained in the model, it has to be summed up for the volumes of these two cones and the cylinder. And for that, let's find out the height of the cylindrical portion. So height of cylindrical portion is 12 minus 2 minus 2, which is 12 minus 4 is equal to 8 centimeter. Now, the volume of air contained in the model's volume of air contained in the model is equal to the volume of glucose plus volume of cylinder. Now the volume of the cone is 1 by 3 pi r square h, and the volume of the cylinder is pi r square h, but we have two cones, so it has to be multiplied by 2. And I'm keeping the height of the cone as h1 and height of the cylinder as h2. So this is the height of the cylindrical portion, which is h2. So let's say h2 is 8 centimeter, which is the height of the cylindrical portion. And the height of the cones is h1, which is 2 centimeter, and the radius is same for the cylindrical and the conical portion. So I will keep it as r square. And let's me take common. So common here is pi r square is common. So this gives me 2 by 3 h1 plus h2. And let's use 22 by 7, and radius is 3 by 2, so it's 3 by 2 into 3 by 2. 2 by 3 into height of the cone is 2, height of the cylindrical portion is 8. So this gets cancelled with 11. So this is 11 into 3 into 3 by 7 into, this is 4 by 3 plus 8. So this is 4 by 3 plus 8. So this is equal to 11 into 3 into 3 into 7 into, this is 3, 4 and 8, 3 are 24. Which gives us 11 into 3 into 3 by 7 into 28 by 3. This gets cancelled. 7 4s are 28. And it's 11 3s are 33 into 4, which is equal to 4 3s are 12. 4 3s are 12, 132 centimeter cube. So 132 centimeter cube is the volume of the air contained the in this model. And let me just check it once again. So 2 into 1 by 3 pi r square h plus pi r square is common, which is 2 by 3 h1 plus h2. Now h1 is 2 and h2 is 8. So 12 minus 2 minus 2, 12 minus 4 is 8. So this is 3 LCM, 24, 28. 11 into 3 into 3 by 7. We all have 2 here, so this is 2. And this is 2, so 2 2s are is 4, so we have, this is 33 into 2, which is equal to 66 centimeter cubes. Sorry, so the volume is 66 centimeter cube. And let's now move on to question number 35. So I forgot to multiply it with or divide it with 2, so this has to be divided by 2, which is 66 centimeter cube. And now let's move on to question number 35. Okay, for question number 35, we have to find the value of x for the given information and then find the mean and the mean expenditure on milk. So this is question number 35, and let's get our class intervals. And okay, let's write down the class intervals, frequency, and then we'll get the class marks. Or we can also write down the cumulative frequency for the median to be evaluated. This is 1000 to 1500, and then 1500 to 2000, 2000 to 2500, 2500 to 3000, and 3000 to 3500. Next is 3500 to 4000, and 4000 to 4500, 4500 to 5000. Okay, now the frequency for all these intervals is 24, 40, 33x, 30, 22, 16, and 7. And now, first of all, let's find the value of x. So it's given that the sum total of the frequency is total of 200 families. So that means the sum total of all these frequencies is 200. So that means it's 24 plus 40. This is sigma fi is 200, and sigma fi is 24 plus 40 plus 33 plus x plus 30 plus 22 plus 16 plus 7, which gives us 200. Now 24 plus 40 plus 33 is 3 plus 4 is 7. 3 plus, okay, 3 plus 4 is 7, and 2 is 9 plus x Let's add these terms. So this 7 and 6 is 13, 14, 15, and 15 is 3, 4, 5, 6, and 7. Plus 75 is equal to 200, which gives us x. 7 plus 5 is 12, 9, 7 is 16, and 72. So this gives us x. The value of x is 200 minus 172, which is 10 minus 2 is 8, 28. So the value of x is 28. So that means we can fill it here, the value of 28. Okay, now first of all, let's find out the class marks, or let's find out the median first. So this is cumulative frequency is 24 plus 40 is 64 plus 33. So 64 plus 33 is 797 plus 28 is 8, 7, 15, 9, 2, 8, 7, 15, 125 plus 30 is 155 plus 22 is 177 plus 16 is 7, 6, 13, 7, 8, 9, 193 plus 7 is 200. Okay, so this is the cumulative frequency. And now let's find out the median class. So n by 2 is 200 by 2, which is equal to 100. And 100 belongs to this median class. So this is our median class. So we can write here the median class is equal to 2500 to 3000. Now let's find out the median. The median is equal to L plus n by 2 minus cumulative frequency upon frequency into h. L is the lower limit, which is 2500, n by 2 is 100. Cumulative frequency is the cumulative frequency of the class preceding the median class, which is 97. F is the frequency of the median class, which is 28, into h is the class size, which is 1500 minus 1000 is 500. So this is 2500 plus 100 minus 97 is 3 into 28 into 500, which is equal to 2500 plus 1500 by 28. So 7 fours are 28. Okay, it's 4. It's 14, and then 2 sevens are is 14, 5 and 0. Now 2 sevens are is 14, 2 threes are 6, sevens are 14, and 5s are 10. It's divided with 7, so it's 7, 5s are 35, 7 threes are 21, 40, 7 5s are 35, 40, and it's 53.57. Okay, so this is 375. I divided it by 7, which gives me 7 5s are 35, 25, 7 3s are 21, 47 5s are 35, 50, 7 7s are 49. So it's 53.57. And if I add it to 2500, which gives me 2553.57, which can be rounded off one decimal, which is 22553.6. So this is the median. And now let's find out the mean, sorry. For that, we are going to use the step deviation method because that will make the values smaller. And for that, I'm going to remove the cumulative frequency. Okay, let's find out the class marks. So the class marks is the upper limit plus lower limit divided by 2, and which gives us, this is 1000 plus 1500 is 2500, which is 1250. 1500 plus 2000 is 3500, which is 1750. So this there is a difference of 500, so let's keep on adding 500. So this is 2250, and then 2750, and then 3250, and then add 500, 3750, add 500, 4250, add 500, which is 4750. Now let's find out. So you do this. Okay, let's get another column. And now we have to find out the deviation, that is di, and this is equal to xi minus a. And for us, a is we have total number of 1, 2, 3, 4, 5, 6, 7, 8 terms. So I'm going to take 8. This is 4. So let's take our assumed mean. So let's take the assumed mean to be, okay, so let's take the assumed mean to be 2750. So this is di, and this is our assumed mean. So 1 to 5 minus 2750. So which is negative. So this is 2750 minus 1250, which gives us 5, 1500, and this is negative 1500. And if I subtract this from 1700 minus 2750, once again is negative 1000. This is negative 500, and this is 0. So it increases here. So this is 1000, and then increases by 500, and then it's 1000, 1500, and then it's 2000 and 2500. Now let's calculate ui for another column, which is ui is di divided by h. H is the class size, which is 500. So this is minus 3, and then minus 2, minus 1, 0. This is 2, and 3, and 4, and 5. So minus 3, minus 2, minus 1, 0. And after 0, it has to be divided by 500. So this is 2, 3, 4, and 5. So minus 3, minus 2, minus 1, 0, 1, 2. So this is minus 3, minus 2, minus 1 divided by 500. This has to be divided by 500, which is, okay, this is actually, it should start from 500. So this is 500, and this is 1000 and 1500, and then 2000. So now this should be, it should be 1, 2, 3, and 4. So H is class size here is 500. So I have divided each of these terms with 500. So this is 500. Now let's find out, this is Fi into Ui, the last column. So this is Fi into Ui. So we have to multiply Fi into Ui. So 22, 24 minus 3 is minus 72, 40 minus 2 is minus 80, 33 into minus 1 is minus 33, 28 into 0 is 0, 30 into 1 is 30, 22 into 2 is 44, 16 into 3 is 48, and 7 into 4 is 28. Okay, let's find out the sum, that is the sigma Fi into Ui. So let's first of all add the negative term, which gives us negative. This is 5, 8, 7, 15, and 3 is 185. So this is 30, 8, 8, 16 plus 4 is 20, and 5, 4, 9, 4, 13, 2 is 150. So 150 will give us, this is negative 35. So this is negative 35. And now let's find out mean. And we have used the step deviation method. So mean is equal to A plus sigma Fi into Ui by Fi into H. Sorry, sigma Fi into H. So assumed mean was 2750. So 2750. The sigma Fi Ui is negative 35. Sigma Fi is 200. H is 500. So this gets cancelled. And mean is now equal to 2750. This is negative. So minus 35 into 5. 5 that is 25. 5 are 15, 16, 17 divided by 2. So this is 2 eights are 16. 2 sevens are 14.5. And 2750 when subtracted from 87.5 gives 5, 2, and 1486. So this is 2762.5, which is our mean. Okay, so this is actually, okay, sorry, this is actually 10 minus 5 is 5, 9 minus 7 is 2, 14, 8 is 6, 6. So this is 2662.5 is the mean. And this is also question number 35. Let's move on to question number 36. We are on the section E, that is the case study based questions of 4 marks each, and it's given that two schools P and Q they decided to award prizes to the students for two games of hockey and cricket. And those who play hockey will be given X rupees per student. So this is question number 36. And for the hockey, it's X rupees per student has to be awarded those who play hockey, and those who play cricket, for them it's rupees 5 per student. Now this school P, there are two schools P and Q. Now school P decided to award total of rupees 9,500. So P is going to give a total cash prize of rupees 9,500, and Q for a total for the two games or to 5 and 4 students. So the prize money remains same for both the schools. So for these are 5 students respectively of the first one game was hockey and the second one was cricket. So if X is a rupees is awarded to one student, for 4 students it is 4x. Okay, before that, let's just write down the information. And Q school it decides to give away a total cash prize of 77,370. Okay, and we have two for these are for 4 and 3 students respectively. So here we have students that is 5 and 4. This is for hockey and cricket. And Q has school has students 4 and 3 respectively for hockey and cricket. Now, based on this information, we have to represent the following information graphically in terms of X. So for P, for one student, it's X rupees. For hockey, for 5 students, is 5x. And for one student, it's Y rupees for cricket. So for 4 students, it's 4Y. And total prize money is 9,500. So this is the algebraic representation for the school P. Similarly, for school Q, this will be 4x plus 3y is equal to 7,370. This is algebraic representation. Now, second says what is the price amount for hockey. So price amount for hockey means we have to find the value of x. So for second part, we have to find the value of x. For this, we have to solve these two equations. And we are going to solve these two equations. So these are the two equations, so 1 and 2. So let's multiply 1 with 4 and 2 with 5. So 1 when multiplied with 4 it gives 20x plus 16y is equal to 0, 0. 5 fours are 20, 9 fours are 36 and 38,000. And when 2 multiplied with 5 it gives 5 fours are 20, 5 threes are 15, y is equal to multiplied with 5 gives 0, 7 fives are is 35, 5 threes are 15 and 3 is 18, 7 fives are 35, 8 is 36. Now let's subtract these two. If this gets cancelled, this is y, and okay, let me just correct this. So this is 7370 multiplied by 5. 7 fives are 35, 5 is 15, and 3 is 18, 7 fives are 35, and 36. This is 36850, and this is 38,000. Okay, it's good. So 0, 10 minus 5 is 5, 9 minus 8 is 1, and 7 minus 6 is 1. So we have got y, but we have to find x. So to find x, let's use the first equation. So from 1, which is 5x plus 4 into 1150 is equal to 9500. Now this is 5x plus 0, 5 fours are is 20 and 646, which is 9500, which gives 5x is equal to 9500 minus 4600. So 5x is equal to 0, 0, 15 minus 6 is 9, 4, and x is 5, 5, 9, that is 45, 80. So x is 90. And the price for amount for hockey is 980 rupees. Now the price on which game is more and by how much, that means we have to find y as well. We have already got that. And for this or part, we have to find on which game it is more. So it's a game on the prize money on cricket is more as compared to hockey, and the amount differ by 1150 minus 980. So for this price on which game is more, so price on cricket is more, and by, let's subtract it. So 1150 minus 980, 15 minus 8 is 7 and 1. So by 170 rupees, the prize money is greater. So the price is more by 170 rupees. So price on cricket is more and by 170 rupees. So third question says, what will the total prize amount if there are two students each from two games? So two students are each. What will the total prize amount if there are two students each from two games? Means that for the hockey there are two students, for cricket there are two students, and what will be the prize amount that's asked? So let's multiply them with, let's take two common or multiply them with 2x plus y. So x is 980 plus 1150, which gives us 2 into 0, 8 plus 5 is 13, 9, 10, 11, and 2, which is equal to 4260. So rupees 4260 is the prize money if there are two students from from both hockey and the cricket. Okay, so this solves our question number 36, that is a case study. Let's move on to question number 37. Here we are on question number 37, where it says that Jagdish has a field which is in the shape of a right angle triangle AQC. So this is the field that is in the shape of the triangle that is AQC, and he was to leave a space in the form of a square PQRS. So this space has to be left for growing wheat. Now the remaining area, that is this one and this one, has to be left for growing vegetables. And in the field there is a pole marked as O, which we have to consider it as the origin. Okay, now based taking O as origin, we have to find the coordinates of P and Q are given, and PQRS is a square. What are the coordinates of R and S? So let's check what is the scale used here when we have to find the coordinates of R. So coordinates of R. So this distance is 200. So this means this is 200 plus 200 is 400. So the coordinates of R are 200 comma 400. So coordinates of R are 200 and 400 on the basis of the scale used. Similarly, we have to find the coordinates of S. So this distance is 400 and this is negative 200. So it's negative 200 comma 400 are the coordinates of S. Now let's move on to the next question, which is on the next page. What is the area of the square PQRS? So we have to find the area of the square PQRS. So to find out the area of the square PQRS, so this length, so PQ, this is for question number 2. PQ is 400 units and the QR is 4. Okay, it has all the sides equal. So area of the square is area of square PQRS is equal to square of any of the sides, which is 1600 square units. So we have got the area of the square, which is 1,63,60,000 square units. Now we have to find the diagonal PR. So this is the diagonal PR. So for diagonal PR, we know that it's under root of, so this is a right angle triangle, 400, this, and this is the high diagonal, is the hypotenuse. So this is square of 400 plus square of 400. Now this square is 2 times, so I can write 2 times 400 square, which is under root, which gives me root 2 into square root of 400 square. Square and square root gets cancelled, and square root of 400 is 20. So this was equal to 2 into square root of 4. Okay, now this is equal to 400 root 2 units. So I have written 400 square as 2 times 400 square. And now this is of the form a root of ab, which can be written as root a into root b. Now root a is root 2 and root b is 400 square. Square root gets cancelled. So this 400 root 2 units is the area of the diagonal. And let's see what is asked next. So we have to find the length of the diagonal is if S divides C in the ratio K is to 1. What is the value of K where point A is 200 comma 800? So the point A is 200 comma 800, and okay, point A is 200 comma 800, and we have to find uh it's S divides C in the ratio K is to 1. So S divides CA. So this is CA in the ratio K is to 1. Now we have got the coordinates of A, and the coordinates of C would be, this is 200, 200, 400, and this is 600. So this is minus 600 comma 0. As per the scale that's used on the graph, we have got the coordinates of C So the coordinates of C are minus 600 comma 0, it's on x-axis, and the coordinates of A are 200 comma 800. Ratio is k is to 1. We have to find the value of k, so this is x1, x2, x1, y1, x2, y2, and this is m1, m2 ratio. So let's use the section formula. So using section formula, now we do have the coordinates of s as well, which is minus 200 comma 400. So the coordinates of s are minus 200 comma 400. So using the section formula, it's x comma y is equal to m1 x2 plus m2 x1 upon m1 plus m2. It's m1 y2 plus m2 y1 upon m1 plus m2. Now x comma y are the coordinates of the s, which is minus 200 comma 400. M1 is k, x2 is 200, m2 is 1, x1 is minus 600 upon k plus 1. And okay, comma. Let's put in the value of respective values here. M1 is k, y2 is 800 plus m2 is 1, y1 is 0, and this is k plus 1. Now we can use either of the values here. So let's try to equate these two. So this is minus 200, which is equal to 200k minus 600 by this is k plus 1, k plus 1. And if we cross multiply this, which gives us minus 200k minus 200 is equal to 200k minus 600. So this gets shifted to this side, which is minus 400k, and this is minus 600 plus 200 is minus 400. This gets cancelled. K is equal to 1. So that means S is the midpoint, and the required ratio is 1 is to 1. Okay, so this solves our question number 37, and let's move on to question number 38. Okay, for question number 38, uh, yeah, question number 38. And the governing council of a local public development authority of Dehradun decided to build an adventurous playground on the top of a hill, which will have adequate space for parking. So this is a parking area, this is a playground, and these are the two reserved special seats. And based on the above information we are given with the length and the breadth, what is the total perimeter of the parking area? So total perimeter of the parking area is this plus this. And first is the total perimeter of the parking area. So total perimeter of the parking area is pi r plus diameter. This is the diameter of the semicircular region, which is 22 by 7. Radius is 7 by 2. Diameter is 7. So this is, and it's not multiply. This is plus. This is plus, which is 11 plus 7, which is equal to 18 units, is the perimeter of the parking area. Now for question number 2, we have to find the total area of parking at two quadrants. So total area of parking at two quadrants. So the parking area is the semicircular region, which is pi r square by 2. Let's consider the radius as r1. And we have two quadrants for which The area is theta by 360 into pi r square. So pi is 22 by 7. The radius of the semicircular region is r, 7 by 2, and has to be divided by 2 plus 2 into theta for the quadrant is 90, 22 by 7. Now the radius for the quadrant is 2. So I have taken it as r2, so 2 into 2. This gets cancelled. This is 11, so 11 into 7 is 77 by 4, and this is 9 4 are 36, 2 2s are 4, 2 gets cancelled, and this is 44 by 7. So LCM is 28, 28 into 7, 4 sevens are 28, 7 sevens are is 49, 7 sevens are is 49, and 3 is 49, and so this is 77 into 7, which is 49, 7 sevens are 49, and 4 is 53. So this is 539 plus this is 4, 4, 16, and 17, which gives me 9 plus 6 is 15, 7, 3, 10, and 11. This is 715 by 228 square units is the total parking area and of two quadrants. And let's move on to the next part. Okay, it's given that what is the ratio of area of playground to area of parking area, and for part B, that is all you have to only one of them. Now the ratio of area of playground, so area of playground to the area of parking. Now the area of the playground is length into breadth, which is 14 into 7, and the parking area is pi r square by 2. So this is pi r1 square by 2, which is 14 into 7. This is 22 by 7. Radius is 7 by 2 into 7 by 2 into 2. Okay, this can be written as 14 into 7 by 22 into 2 by 7 into 2 by 7 into 1 by 2. This gets cancelled. 7 and 7 gets cancelled. This is 2, 11, and 2, 7, which is equal to 14 by 11. So the ratio is 14 is to 11. The parking area ratio is 14 is to 11, and let me just check it once again. So it's 14 into the length is 14 and the breadth is 7. That is the area of playground to area of parking area, which is pi r1 square by 2. So pi is 22 by 7, radius is 7 by 2 into 7 by 2, and this should be half. This should be half, and when it goes up, it should be now. So this is 14 into 7 into 7 by 22 into 2 by 7 into 2 by 7 into 2. So this 7 7 gets cancelled, so it's 2 into 11, and it's 14 into 2 is 28, 28 into 2 is 56 by 11. So the ratio is 56 is to 11. 56 is to 11 is the required ratio. Now, for question number third, it's given that we have to find the cost of fencing the playground. So that means the total playground has to be fenced. This is the playground and the parking area. So we have to find the cost of fencing the playground, and for that we have to find the this length, which is the perimeter. So perimeter of playground and plus. So let's add the perimeter of the playground that has to be fenced plus the perimeter of parking area, which is 18. So perimeter of the playground is 2 into L plus B plus perimeter of the playground parking area is 18. So length is 14, that is 7 plus 18. 14 plus 7 is 21. 21 into 2 is 42 plus 18, which is 60. So 60. Okay. And okay, this is the actually the total perimeter of the parking area, but we have to find the parking area. So this we don't have to include for the parking area. We will just consider this because this is already included in the playground. And now this is pi r. So pi r is 22 by 7 into radius is 7 by 2. So this is 11. So that means we have to add just 11 to the perimeter of the playground, which is 42 plus 11 is, this is 53 units. This is the total perimeter, and now we have to find the cost of fencing. So cost of fencing is, it's given, the cost of fencing is rupees 2 per unit. So this has to be multiplied by 53, has to be multiplied by 2. So 53 into 2 is 106 rupees. So this is the cost of the fencing. And this completes our this the set. Please do like, share, and subscribe. Thank you for watching.